Right, so we've still got a few people to rejoin, but I think in view of time, we'll kick off with the afternoon session, and I'm going to give a quick review of where we got to anyway. So if there's anybody still to join in the next couple of minutes, people will be able to pick up. So welcome back, everyone. Hope you had a good lunch break. We're going to carry on with what we looked at this morning with the process of getting ready to build Singularity images. So I'm going to give you a quick review of where we got to, and I'll just go through the what we were looking at with the Docker Singularity image. So we looked this morning at the process of working with Singularity to run images that we've pulled either from Singularity Hub or Dockerhub, and we talked about how the fact that within Singularity we are effectively an unprivileged user. We have the same privileges that we have on the system where we run the Singularity image. But what we want to be able to do is to create containers, create images rather, to run containers that are based on our own images with our own software installed and so on. And that's what we're going to look at this afternoon. We talked about the challenges of being able to have access to Singularity in an environment where we've got privileged root access. And to get around that, we're going to use the Docker Singularity image. So if you recall, Docker Singularity image is stored in the key.io repository. There's the page with the repository, and there's a link to that in the material. And we were looking at using the version 3.7.3 slim Docker image. And I also highlighted that if you are trying to build on an ARM system and you want to follow along, although this will build it, if you follow along using an ARM image, you'll get an ARM-based image at the end, which you won't be able to transfer over to ARCHER2 to run. It will at least let you follow on with the process, and we will provide you with a ready-made image on ARCHER2, an x64 image, an x86 64 image that you can use if that's the case. So if you do want to follow along just to see how the process works, there are also ARM images, and I'm highlighting one there, 3.8.2 slim ARM would be an option for you. So we're looking at how we can run this Docker Singularity image on our system, and we looked briefly at the process, but I'm going to just take you through again where we're at and what we're trying to do. So we're going to use our Docker knowledge from yesterday to run this image. We've got the image tag that we want to run, and I've also highlighted here that you should create a directory on your host system in which we can work to put our input files for generating our image and where we can get our built image out. So if you go ahead and create a directory in your home directory called Singularity Data, if you want to call it something else, you're very welcome to, but that's the name I'll be using for my system here. So if I change to that directory, which I've already previously created, I've got the directory there, home Singularity Data, and you can see I've got some previous content in there, but that doesn't matter for now. And that's the location where I'm going to work from. And what I'm going to do is I'm going to bind mount that directory into the Docker Singularity container at the location home Singularity. So every time that I run the Docker Singularity container and I run the Docker command to create an instance of that container running Singularity, I'm going to bind mount the home Singularity data directory on my local machine into home Singularity inside that container. And as we'll see, the command line gets a little bit unwieldy, it gets rather long, and it's a little bit complicated, but hopefully based on what you learned yesterday, you'll be able to follow what we're doing. So we know we need this mount, the mount switch to put in the mount. We've also looked earlier at the fact we need this privilege switch, and we're going to also use the --rm switch to remove the container when it's finished running, and we're going to use -it so that we can get an interactive terminal access if we need it. So that's all the different flags we're going to put together to run this command. So in these exercises here, the questions and exercises, which we very briefly I think we just got to this point before we broke for lunch, it says, can you run a container from the Docker Singularity image? And don't forget to add the tag version. So hopefully before the break, you all managed to at least be able to run the container and get it to you could see that it was running the Singularity command within the container that started from the Docker Singularity image. Hopefully you got to that point. Then we have another question or exercise. Can you run an interactive shell in the Docker Singularity container? So again, hopefully from yesterday's Docker material, you have some recollection of how to do that. Note that we're saying to run the shell bin sh, not bin bash. That's because if you're using the slim container, it doesn't have the bash shell installed. It just has sh, which is a cut down version. So if we want to run an interactive shell, we could do that as follows. So it was also highlighted. Somebody's asked what's the equivalent of the alias command for Windows PowerShell. I have to say, I'm afraid I don't know. If we've got any Windows PowerShell users here who are familiar with that, maybe they can respond to that. We'll come to look at that a little bit later when I look at the alias anyway. So if anyone's wondering what that's in reference to, that's in reference to a section a little bit further down talking about the alias command. So we'll look at that in a moment. It was also pointed out earlier that I'm using in my command Docker run, but in fact we used the command Docker container run yesterday, which is the newer version of that command. So Docker run, Docker container run is basically the same command. It's just Docker run is the older version. Docker container run is kind of the newer accepted approach. So they are interchangeable, but I guess for consistency with yesterday, I should be using Docker container run. So as a reminder, we're going to put together our various different switches. So we're going to say we want interactive terminal access. We want RM to remove the container when it drops out. We want privileged. We're going to see in a minute how to avoid having to type all this every time. And we're going to tell it which container we want to run, which is key.io/singularity/parity 3.7.3 slim. I think that is correct. And we also need to bind mount our directory. So let's add that in as well. So mount type equals bind. Source is home singularity data. So that's the location I've created here in my home directory. And the target is home singularity. Hopefully I've got all that correct. And what we also want to do in part 2 here is try and run an interactive shell. So we're going to do that by overriding the entry point. So before I do that, let's just check and we can just test that this actually runs a singularity command. Indeed it does. So that's run the singularity command. We haven't provided any parameters at the end of the command where we would normally put the parameters to singularity to tell it what we want it to do. So it just dumps out a bunch of usage instructions, just the default help. If we wanted to override that default running of the singularity command and give ourselves access to a shell, we can override the entry point and put bin sh. And we then get into a shell inside the Docker singularity container. We're in the root directory there. If I go and look in home singularity, I should see that I've got that content folder that I had in my home singularity directory on my machine. And if we type singularity, we can run it. So we've now got a machine where we have root access because we're in the Docker container, recall, as a user root, and we have singularity installed and available to us. So that shows us how we can use singularity in an environment where we have root access. So that was question 2 there. And we have already bind mounted the directory here because we used the --mount parameter to singularity to Docker to be able to do that. And there's then another question asking, can you run an interactive singularity shell in a singularity container? So this is starting to get a little bit more complicated. It's really just to try and give you an idea of the concept of the fact that we're running one system inside another. So if I open up the answers there and just work through those, so we can see that we've got as far as running the shell. And this basically takes us to the point where we got to, where we were able to run an instance of the image with the directory bind mounted, the home singularity data directory. I've just used $pwd. If you recall from yesterday, that just takes the current working directory and bind that into the container. And we've used -rm to remove the stopped container when it exits. I don't have -it here. if I wanted to, well, as I did, as I ran a shell there, I needed to use IT to get access to get interactive access to the shell. So it's useful to add that in as well. So I'll just drop out of the shell for now and just show you again that if we were running so that was the previous version of the command where I didn't have the entry point, and I just ran that just ran Singularity on its own. If I then put something at the end of that command, so in other words, the standard command we might want to try is cache list, so Singularity cache list, you can see that we've got the output that we saw when we were in ARCHER2 when we looked at the cache. So we can see that that is able to read the cache. And excuse me, in this case, the cache is empty because we haven't actually done anything in terms of working with containers, and that cache is actually inside the Singularity Docker container, so there's nothing in there at the moment. It's just an empty cache. With this next one is looking at the question about running a Singularity container inside that Docker Singularity container. So it's basically running Singularity inside Docker. It's probably not necessary for us to go into detail of that at the moment, but this was just to show basically that it's possible. So do feel free to give that a try, and we can certainly come back to look at that if depending on time a bit later on. Happy to come back and have a look at that. So to summarize what we've got here, we've got basically a setup where we have access to Singularity inside a Docker container, which we can access either by opening a shell inside that Docker container and just running the Singularity command directly at the command line. That's one option. Or we can use the Docker run or Docker container run command to run a new container instance every time we want to run the command. So basically, every time we want to run the Singularity command, we could just run this command every time with the whatever it is at the end. So here we ran cache list. We could run build and then something at the end if we wanted to, or whatever. So that's running a new instance of the Docker Singularity container every time we run the command. And either option is fine, but we're going to take the approach of just running the container every time here. So we're going to use this. And to save us having to type this extremely long and not very nice looking command, it's just there's too many different switches there, and we certainly don't want to have to type it out every time. We're going to use an approach of setting up an alias. So for those of you familiar with Linux, and this will also work if you're in a bash shell on Mac, if you want to, you can create an alias so that when you type a particular command on the command line, it's basically a link to some other longer command or some other different command. So if we set up the alias by saying alias Singularity equals this long string here, every time we just type Singularity on the command line, it will run this particular command for us. So it's a much easier way of doing it than having to manually type out the whole command every time. That will, by default, that will persist only in the current shell. So if you close that shell session, then if you close the shell session, sorry, I'm just looking at a message in the chat there. I'll come and address that in a second. Then that alias will not exist anymore. But you can persist the alias by putting it into your bash profile. If you're familiar with Linux, you might be familiar with the bash profile that's used to create your kind of default environment. That's probably beyond the scope of things here, but this is just to point out that you can create this alias. So I'm gonna do that on my system. Hopefully you'll be able to do the same. If you're on Windows, there was actually some information about how to do that in PowerShell on Windows in the chat there. So if you're using Windows, if you take a look in the chat, there's something there telling you to use the option set alias, I think. And as I say, if you're on Mac or Linux, this should work straight off. Equally, if you're in WSL, Windows Subsystem for Linux on Windows, you can just use the alias command. That should work fine. So hopefully that covers all of the different platforms. So I'm going to create this here. So I'm going to actually just use the command that I've got here. That's probably the easiest option. So I'm going to say alias Singularity, spell it correctly, equals that. And now, every time I type Singularity, oops, did I spell it correctly? Yes, I did. Oh, I've just realized what's going on. I'm so sorry. This is me confusing things because I don't use bash as my default shell. I will switch to bash shell so that it all works perfectly, right, and then run that. Oops. So create my alias, and now when I type Singularity, I have Singularity, and it effectively looks like Singularity is installed on my local system. But in fact, every time I type that command, it's then starting a Docker container, running the command, and then exiting the container. So it kind of wraps all of that up in one command. There's a question in the chat there: will the alias only persist as long as you keep the terminal open? Yes, that's absolutely right. So I was just saying before, yes, it will only persist in the current terminal session, in the current shell session, but you can add it to your bash RC as just been put in the chat there, or bash profile, which contains things that are configured, sort of standard configuration that's configured every time you start a shell session. So right, so somebody's saying there if they use PWD, it works, but if you try with home singularity underscore data, that should be. I wonder if the underscore's got as missed. I don't know if that's a typo. You get invalid arguments. So type bind source root. So the source directory. So what is so you seem to have source set as root singularity data. Is root are you currently set up as root on your system? Are you currently running as root on the system that you're running this? Because that suggests that you are. Right, okay. And right, and have you got a target set? Because it might be that you can't set up the oh, I see, it says invalid field. So I think I'm just looking at, you might need to set a target. I don't know whether any of the helpers can assist with that, but I'm just looking. It's interesting that PWD works, but home singularity doesn't. If you type echo $home, do you see /root as the home directory? Because it could be possibly that that something's got mixed up with the home setting there, and in fact home is not set to /root. Right. Hopefully that's been resolved, or if not, one of the helpers can assist with that. Hopefully then we've all got to the point where we can run this container. So let's just put up a little poll again, and just check that people are able to keep up and have got that running. Open that up and see how people are doing. Okay. Yes, so there's a point there in the chat that's made that yes, if you've got a space in the mount string after one of the commas, that doesn't seem to be accepted by Docker. It seems to not like that. So that's a good spot there. I'm glad that was resolved. So many people seem to be doing okay. If you've got a problem, feel free to put up your hand. If you've got a question you want to ask in the if you want to ask in person, or just type in the chat, it's absolutely fine. And I think, assuming that most people are okay, we don't have any no's at the moment, so I'm guessing that in general people are okay. If you're stuck, do let us know. Okay, so we haven't got any no's at the moment, and the vast majority of people are saying yes. So I think we'll proceed, and there'll be help available if you are stuck. Just let us know. Right. So we've got to the point now where we have this set up with Singularity running, and I've shown you here. I can type Singularity at my terminal, and it's running the command via the container. So we've got to the point in this section now where we have shown how you can use a Docker image to run Singularity on your system with root privileges, and this means you don't have to have Singularity locally installed. If you're running on Mac or Windows, you probably don't have that option anyway. And you can also run Singularity containers within the Docker Singularity image if you want to. It's not probably the recommended approach, but it is an option. So this is quite a flexible tool to use with this Docker container, and it's a great way also to build on your knowledge from Docker, Docker knowledge from yesterday. So we're going to continue with using this. So we've already done our lunch break, so we'll skip over that. And we're going to continue now looking at how to actually build some images. And so there was a question earlier about why are we doing this rather than just using Docker images? And I guess, I mean, one thing is just to remain within the Singularity ecosystem and to show that we can do that. That there's added kind of complexity if you're working with multiple different systems. The other thing to bear in mind is also, of course, if you've got content with sort of data or software that you're working on that you don't yet want to make public, maybe it's something that's a work in progress, or there's something that you don't want to make it publicly available. Docker, I think you can have maybe one private repository by default with Docker, but I believe, and somebody can correct me if I'm wrong, that I think if you want more private repositories to store stuff on Dockerhub, you now have to pay for it. Certainly, I think for education use, it's free to use, but I'm not sure if I don't know that you can have multiple private repositories. So that could be a problem. And so if you want to keep entirely within the Singularity ecosystem, then this gives you the option to do that, building Singularity images yourself. You can, of course, start from a publicly available Docker image. We'll show how to do that in a minute. But it means that you don't have to go through Docker, as it were, in terms of pushing this to Dockerhub or whatever. You can work entirely within the Singularity ecosystem. So there are a couple of different approaches to building images, and one of the things that I really wanted to highlight at this point is that this Singularity is generally is used widely on HPC infrastructure and on HPC platforms that are used within the scientific and research communities. And of course, a really big issue within our community is reproducibility, and particularly when things involve software and data and it all gets terribly complicated, it's very easy to produce code that is not able to reproduce the results every time. If, for example, you've got an error in the code somewhere, or something is wrong in the workflow that you're using, it's reproducibility is something which is hugely important, but it's also very easy to not get it correct. And so if you are building an image which you want to make available either just for yourself or your own team to use, or if you want to make it more widely available, it's really important to have something where it produces deterministic outputs and produces the same results for a given input every time. And so the containers in general are great for supporting reproducibility, and we saw that with Docker yesterday with some of the material towards the end of the session talking about this. And Singularity obviously is no different. But how you build your image does have a bearing on how easy it is to ensure that things are reproducible and how easy it is to provide provenance and understand why something works a particular way. And so there's a couple of things I wanted to highlight with the ways that you can build images, and the two options are to build with a sandbox or building from a definition file. And the building within a sandbox option gives you the ability to effectively build a container interactively as you go along. And I think somebody was asking about this yesterday when we looked at Docker, whether there's an option to do that. So here with a sandbox, you literally create effectively a directory with a kind of base system in it, and you go ahead and you manually edit files in there, and you install the software in that you want, and you edit configuration files and settings files and so on, and you go through all of this process, and then at the end, when you're ready, you just bundle it up as a .sif Singularity image file, and then you've got your image that you can work from. The other option is to use a Singularity definition file, and this is very similar to the idea of the Dockerfile that we saw yesterday. And with this, you create some file with a set of commands in it, and those commands are run. So it's just a text file that you start from. It has a set of commands, and those commands are run in turn to generate the resulting image. And there's a bunch of documentation. Singularity's documentation on building a container is great, and that gives you some details on the different approaches available there. So a question is, why do you think we might be looking at the definition file approach rather than the sandbox approach? Some people may feel that the idea of using a sandbox is actually easier because you just go in and work through step by step until you've got something that you want. Does anybody want to suggest why they think we're specifically focusing on the definition file here, particularly in light of what I commented earlier? So yeah, we've got an answer there for reproducibility. That's absolutely right, and that's probably the main reason. So yeah, so that's actually what I was going to highlight. So the point there is that we all know that if you're used to working certainly on a command line, and you're used to either building software or configuring software, it's very easy to think you know exactly what you want to do, and to sit down and go through the process of doing exactly what you want and say, right, it's all done, I'm going to run it. And you run it and it doesn't work. And then you realize, oh, I just made one mistake. I didn't put the right setting in this file. So you go and edit that file and you put the setting right, and then you run it again. And it's almost there, but then you realize actually something else changed. Maybe a version of the software that you're using changed, or one of the dependencies changed, and it still doesn't quite work because something's slightly different. So you fix that. And maybe this goes on for a while. Sometimes it can work straight away, but sometimes you can find yourself spending quite a lot of time doing something which you thought was going to take you 2 minutes, and actually it's taken you a lot longer trying to fix lots of little issues. And that's all very well when the thing works at the end of it, but actually it's really difficult to, even if you've documented the process, but especially if you haven't, to know exactly what you've done to get to that end result. And what that means is that if you need to reproduce that container, especially if you've created an image that way and you're using that image to run containers that generate scientific results, it's really, really difficult if you need to get something else that replicates that configuration to get back to that again. So this is something which is a big problem in the scientific community, and Singularity definition files provide, as do Dockerfiles, a much better way to support this idea of reproducibility. So we've got a question that says, why is Dockerhub storing images and not Dockerfiles? So that's a really good question. And I guess there are two different sides to this, because the Dockerfile or the Singularity definition file is, of course, a much smaller artifact. It's just a text file. And it would seem logical that storing it is the best option. It's still the case that if you build something from a definition file, then you could potentially end up with different versions of, or something which is slightly different at the end, if you don't take a lot of care in the process that you use. So as we saw yesterday, and we'll see again today, when you create your definition file, you might have commands in there such as, if you're using an Ubuntu Linux container, you might have something like apt-get install Python 3 or whatever it is. And of course, over time, these package repositories get updated, new versions of the packages get put in place of original ones. And so if you're not actually specifying directly the versions, then you can get something different. Andy, you're going to add something to that. Oh, I saw Andy's hand go up. I wasn't sure if he was going to make a comment. No, maybe not. No, we can't hear you, Andy, sorry. Ah, I think he might have just got cut off. Okay, we'll give him a minute to. Ah, if you're there, Andy, if you wanted to say something, please do go ahead. Looks like you've reconnected. No, we're not hearing anything at the moment. Okay, I'll carry on, but just jump in. Just jump in as and when you're, if it's the microphone comes back to life. Yeah, so I think maybe Andy's got something more to say about that. But certainly one of the issues is that if you have once you have a final container, that is in its own. Ah, are you?
I think I'm back. Can you hear me?
Yeah, now I can hear you. Yes, it's working now. Yeah.
Perfect. So actually, I was going to say, I mean, it's really a convenience thing, and I think it's where Docker came from rather than anything else. So Docker's really originally it was an enterprise IT tool, essentially. You know, we're talking about it here from a research perspective, but the vast majority of usage of Docker is for ways to run web servers and web services and things like that. Right, and when you're running those sort of things, you're usually paying for resources on some sort of commercial cloud, be it AWS, be it Google Compute Cloud, be it Azure, be it whatever. So everything that takes time to set up is costing you money, right? And a build of a container image takes a large amount of time, especially on a low-powered resource or a cheap resource. Whereas running a web server is very cheap on a low-powered resource. So if you've got already built the image, then just pulling it and running it is very cheap compared to having to build it every time you want to start up a new copy of your web server or whatever it is you want. So I think that's actually the real driver behind storing images on the Dockerhub rather than Dockerfiles. A good entry on Dockerhub, though, will include the Dockerfile or a link to the Dockerfile as part of the metadata on the Dockerhub, so you can see how the image has been built. Often they'll point to, for example, a GitHub repo, because many people have automated workflows for building Docker images. But I think that's the real driver for storing images rather than Docker files, because it's not a research tool, essentially.
Yeah, thanks, Andy. No, I think that's absolutely correct. Of course, if you come to run a container, one of the huge benefits of Docker is that you can just say Docker run Ubuntu 20.04 or something like that, and within a matter of 5 seconds, you've got a container that's spun up and ready to go, that's been pulled down from the Dockerhub and is ready to run. And of course, if you had to build that from scratch from the original definition file, you'd be looking at something that takes a lot of resources and takes a lot of time as well. So yeah, I absolutely agree that that's likely to be the main reason for that. But as Andy pointed out, many containers do store with them. Many images on Dockerhub do provide also the Docker file, so you can see the kind of provenance of how it was set up and where all the different things have come from. Okay, so that's really the argument for working with definition files rather than just a sort of ad hoc approach of building stuff and then bundling it. And we're now going to look at something which I guess will probably look to you reasonably familiar from yesterday when we looked at Dockerfiles, looking at creating a Singularity definition file. So this is effectively Singularity's equivalent to the Dockerfile, as I've said already, and it follows this configuration as code principle that I think may well have been mentioned yesterday, where you're effectively storing your configuration in a manner that makes it very easy to store alongside and in the same way as pieces of code. If you're using a repository like Git or GitHub to store things, this provides you with a great way to be able to version your configuration files. And of course, then if you change things, you can just update the definition file, and you're not having to store some huge binary blob every time you want to make an update. So this is a really efficient way to maintain your configuration, notwithstanding, of course, the point that I made about the fact that things can change in terms of versions of packages and whatever. They shouldn't be hugely significant, but depends on how critical what you're running is to this particular versions. But that aside, this is a really great way to manage this. So we're going to start by looking at a really simple definition file. So here is probably one of the most basic definition files that we could create. It's got a number of sections which I'm going to go through, and what we'll then do is we'll look at actually using this to run the build of an image. So we can see here, I'm going to walk through the different sections. But what this is basically doing is this is going to install Python 3 it's going to start from a base container, Ubuntu 20.04, and in fact that's going to come from Docker, from the Dockerhub, and it's going to install Python 3 there, and then it's going to run a really simple Python command. So let's have a look at how that's actually done in the context of the definition file. So the definition file has a number of sections. Each of the sections has this %sign prefix, and these are used to define different elements of the process of building the image. And you can find the full details in the definition files documentation through that link there, which will take you through to some information about each of the sections. But in our very simple example here, we're just using two of those sections at the moment. We're using the post and run script sections. So let's go through and just go through the different sections and look at what they each do. So right at the start, as I mentioned, we've got this thing which tells us where we're going to start from, what base image are we starting from. And I think in the Dockerfile, you saw the thing which said from at the top, and it said what the name of the image was that we're taking things from. This is very similar to that, but we have this bootstrap command at the top, and that tells us what type of platform we're bootstrapping from. So in this case, we're going to bootstrap from a Docker image. If we were bootstrapping from an image on Singularity Hub, I believe we would have shub there. Again, all the exact settings are in the definition file documentation. But here we are saying that we want to bootstrap from Docker Hub. So we say bootstrap Docker, and then we say which container or which container image on Docker Hub we are bootstrapping from. In this case, Ubuntu 20.04. And so that's what the place that we're going to start from. What we're then going to do is we're going to use that as the base, and we're going to change that base image by adding into it what we want to install into it for our particular image that we're creating. So we next have this post section, and in this section of the file we can do things that are things like installing packages, installing pieces of software that we might want to pull in from other places. We can bring data files into the image, etc. And these are basically a set of shell commands that run within the context of that new container image. So we've got our base image that we've started from, and then we're going to run a series of, in the post section, a series of shell commands that do things. So these are very similar to when you saw the Dockerfile, the run commands with the capital run that you have at the start, and then you have a command that gets run. This is very similar in context to that. And so the commands that we're running here, we say apt-get -y update. So this is updating the package index in the Ubuntu container. -y just tells us not to prompt. It just automatically accepts any prompts. And then we want to install the Python 3 package. And that should then go ahead and do that installation, put all the various packages of Python 3 package, and any dependencies will get installed. And we then have the run script section, and that is the thing which says what command to run when the container runs. So if you recall, when we looked at this right at the start, we looked at the Singularity inspect command. So we looked at Singularity inspect -r, and then the image file name, and that showed us the command that was going to run by default when the container was run. That is what comes from this run script section. So if we create this image and then we run Singularity inspect -r on the image that we've built, what we will see is this string will be what's being set up as the run script, and we can prove that a little bit later when we build the image. So we've done this process of taking our bootstrap image that we're starting off from. We've then said what we want to install in it, and we've then said what we want to run by default when we actually run the image, run a container based on that image. So what we would then do is save this definition file to a file on our file system, and we can then pass it to Singularity build, give it the definition file, and tell it the name of the image file that we want to create, and Singularity will then go off and build that. And we're going to do that in the context of this Docker Singularity container. So here I'm showing you an example of the command, Singularity build. And just to note that, of course, on my system, I've set up this alias. Many of you may have done the same thing. So I can simply type Singularity as it's shown here. But if you haven't set up the alias, or if you're on a platform where for some reason the alias wasn't working, you would instead have to replace the word Singularity with this long Docker run command, or at least as far as this point here, this long section of Docker run command will replace Singularity, and you'll see that then after that it's just the parameters that are passed to Singularity which are the same in both commands. So I hope that makes sense. So what we're saying is Singularity build, and we're saying what is the name of the image file we want to create. So that's the name of that file. And what is the name of the definition file that we want to use to create that image? And there's something to note here that it can be a little bit confusing. I've prefixed both of these with home Singularity. Bear in mind that this Singularity command is running in the context of the Docker Singularity container. So it's running inside the Docker Singularity container. So the paths that I provide to these files have to be the locations of these files within the Docker Singularity container. So when I've done the bind mount of my current directory on my host system, so we saw that when we created the Docker command, I've bind mounted the current directory, or in my case, my home Singularity data directory, to the location home Singularity. So as far as the Singularity command is concerned, it can't necessarily see other directories on my system. It knows that the files that I want are located in home Singularity, and that's why we use that /home/Singularity. So it may be that /home/Singularity doesn't exist at all. In fact, it probably won't on your host system. But within the context of the Docker container, it does exist, and the files that are in that location are the things that we've bind mounted into that directory. What that means is that this will go off and build the container, and when it finishes, the CIF file, my test image, or whatever you want to call the CIF file, will be available on your host system in the directory that you bind mounted. So there's sort of multiple levels of indirection here, and once the thing is built, it's placed in the bind mounted directory in the Singularity Docker container. The container then dies, it exits, and we can then access that file on our host system. So I hope that that's clear. So there's a question there: why not always use the same directory structure? Up to a point, you could do, of course, because on most Linux systems, /home is a directory where all the home directories are located, where all user home directories are located. Firstly, if it's not your own machine, you probably don't have access to run that. That maybe if you're running Docker on it, it probably is likely to be your own machine, or a machine that you have admin access to. But it would mean that you'd have to create a directory. If you wanted to use, for example, home Singularity, you'd have to create a directory home Singularity on your host machine. If you looked at it the other way around, can you create a directory that's the same as the one on your host machine in the container? Yes, you can. You could do it like that. In this case, it's I've just opted to do it using the sort of the standard home directory of the Singularity user within the container. But yeah, you could create something that was the same structure. Yeah, that would certainly be an option. But here we're doing it by just simply specifying the home Singularity as the location. So what we can do now is we can actually go ahead and have a go at building this. So if you take the so yeah, I think that's what's been suggested there. Andy's just put a message in the chat. I think that's what. So there's a really good question there about, is it not less resource intensive to run interactively the Docker Singularity container directly? Yes and no. I mean, technically, I suppose it could be, but actually, one of the main benefits of container platforms such as Docker is that the overheads are very low of creating and of spawning and destroying containers. So there is some overhead there, yes, but I think that the overhead is sufficiently limited that if you just start the container in the context of what you're trying to do, the overhead is not sufficiently significant to suggest that you should work within the container all the time. And of course, if you're just doing a build, then you spawn the container, you do the build, and then it drops out, and then that's basically, you've then got your image, and that's probably what you want. So that's I think that's a really good question, though. But yes, it's something I don't think it's sufficiently significant in this case. If anybody else happens to be an expert on the overheads of Docker container creation, maybe somebody else can comment on this. But I think do we have a question there? I just heard something ping. I wasn't sure if there's somebody with a question in the chat. So bear with me a second. No? Okay. Okay, right. So what I'm going to do is I'm going to take this script, and you can do the same. Just copy and paste it from there. And I'm going to, in my home Singularity data directory on my system, I'm going to create file called my test image.def. So that's the Singularity definition file, and I'm going to paste the content into that, and I'm going to save it. So I've now got that definition file here. What I can now do is say Singularity build home Singularity my test image .sif. So this is the output file. So we start off by saying build into this image file, which doesn't yet exist. It's going to create that as part of the build. from the definition file myTestImage.def. That's what I want to do. So we hit enter on there. So something's happening. It says starting build. So this is all happening now inside the Docker Singularity container, even though I ran that command just on the standard terminal on my system. So what it's done is it's spawned the container, and it's then taken the base Ubuntu container, and it has, just scroll up so you can see what it's done. So it's taken the base Ubuntu container, it's updated the package directory. This is what we see, it's getting all of the new package directory information, and it's then run the command to, it's done apt get update somewhere, I think, as well. There we go. Yes, sorry, that was the first bit where it's getting the package information, and then it's done the install of the Python 3 command. We can then see all the standard output that you get when you install packages on Ubuntu, telling us what packages are going to get installed. It then goes off, pulls all the new package files and installs them. And eventually, when it's done all of that, we get various different warnings and bits and pieces. We see it's doing all the final setup of the packages. So this is all standard output from Ubuntu itself. And then at the end, Singularity says adding the run script. So that's adding the script that we put under the %run script section. And then it generates the CIF file, the image file at the end. And then it tells us the build is complete. And because we bind mounted this current directory into that container, we should see the image output file in this location. There it is. If I do an ls-l, you can see it's about 63 megabytes or so in size. And that should be our Python image. And what we can do, sorry, that should be our Ubuntu 2004 image with Python 3 installed. And what we can do to prove that how the run script was put in, if you recall, we can say Singularity inspect -r, and again I have to do home Singularity as a prefix, and my test image.cif, and what we see there is that script that we provided under the run script has been basically bundled up into a shell script with a standard header that you get at the start. And that's what's been put in as the run script. So what we could do is, as a test here, we can run it. So there's actually a couple of, so just before I go ahead and do that, let me just check if there's some questions there that I can refer to here in the chat. Is there anything I need to go through there? So there's a question about whether you can extract the Singularity definition file. So I think if you look at I don't know if it's there by default, but if you do an inspect -all, I think you can see the definition file in there. Let's just try that. So yes, so here you have the def file. I don't know if that goes for all images, but so if you do a Singularity inspect -all on an image, there is a section in the metadata that comes out, def file, and that basically is the contents of the definition file that we originally started from. So yes is the answer. It is there, and I don't know. I presume that's a standard thing, but I'm not 100% sure. Is there anything else there? That anybody else had any other questions? So there's a question there about cleaning up Singularity images. No, I don't think so. Exactly, as that's been answered okay by Andy, so that shouldn't be an issue. Okay, I think that's probably everything there. So in terms of running a container from the image that we built, we can do that, and we can do it within this Docker Singularity container just for testing purposes. So we can again run Singularity run. Then we can say home Singularity. Bear in mind again that this is all using home Singularity as the prefix because it's the location that we bind mounted the files to inside the container. So we're running here the Singularity container inside the Docker Singularity container. Hope that makes sense. Gets a little bit confusing quite quickly. So we can try that, and sure enough, it's run that command that we saw as our run script. You can actually see it's Python command which has printed out the version of Python that's installed, and that was the output. So that was a very simple container a very simple image that we built, and we run the container from it, and that is the basics of how you would build a Singularity image. Sorry, there's a question there about inspecting the run script. So there were two things that I looked at there. So there was the inspect -r, which is what we looked at earlier on. So if I can go back and run that. So that's Singularity inspect -r, and then the path to the image, which is inside the container, is home Singularity myTestImage.sif. So if I run that, that shows you just the contents of the run script. And the other one that I showed was if you use --all, you get much more detailed metadata output from Singularity inspect. So if I run that, you can see there that there's a bunch of additional information, and there's also the def file being shown as well, the definition file contents. Okay, so I hope that everybody is able to get that to work and has managed to keep up to this point. I'm also hoping that people are not having major problems with permissions. So there's a little note here about permissions. Things are changing over time, and I think at one point there was a problem with the permissions. I think with newer versions of Singularity, it's probably not an issue, and certainly if you're running within the Singularity Docker container, it shouldn't be a problem. So hopefully that's not causing a problem for people. Some other things to look at here. There's a note here about the configuration. So as we saw here, we've run our image. So I'm just looking through. We've run our image locally, but I'm just looking for any points that I want to particularly clarify there around ARCHER2. I think we're going to come on to look at this when we actually move on to ARCHER2 in a moment. So of course, this CIF file that we've built is all very well that we can run it in a test context locally in our Docker Singularity container. But what we're really interested in being able to do is to build something that we can run somewhere else. And what we could do, so with Docker, what we might do is send it to Dockerhub and then pull it on the other platform. But because it's just an ordinary file, there's no sort of fancy stuff with different layers, and it's not held within the within a local repository across these multiple layers that you have with Docker images. It's just a regular file on the file system. We can just copy it to another machine. And so what I could do if I want to run this on ARCHER2, as an example, is I could literally just copy the file across to ARCHER2 and then run it there. So the way that I could do that, there's some different options, but I'm going to actually just use SCP. So I don't know how familiar people are with this, but some of you may be familiar with moving files around using SCP. There's a little bit of a description here about SCP is secure copy. It's a pretty standard Linux command. It's built on the SSH system, so it uses SSH effectively to securely copy the data to some other location, and we can copy it across to ARCHER2 using the approach that's shown here. So we've got our .sif file. So what you can effectively do is, in the same way you might SSH to ARCHER2 by saying SSH -i, then the path to your key, and then login.archer2.ac.uk, or other user at login.archer2.ac.uk. What we do here is we can actually just use those elements of the standard SSH command in the context of a copy command. So we say SCP -i, the key that we want to use. So there's the path to our key. Then what we want to copy, which will be in this case the name of the CIF file that we want to copy across, where we're copying it to, which is our user at login.archer2.ac.uk, and then at the end you put a colon and then the path to the location where you want the file to be stored. And in fact, you can actually if you just put a colon with nothing else after it, it will go automatically to your home directory. So I can demonstrate that here. So I'm going to try an SCP. So we can see if I do an ls-l, we can see that I've got this file here that I created, this CIF file, and I'm going to send it to ARCHER2. So I'm going to say SCP -i I'm going to put the path to my ARCHER2 key. And I'm going to say the file that I want to send, which is /mytestimage.sif, and I'm going to say where I'm sending it to, which is my username at, and I'm going to use login4 again because I have a feeling that maybe there's still a problem with the other nodes. So arch2.ac.uk, and I'm going to put a colon on the end, and I'm not going to bother to put / with the long path because if I don't put anything else, it will just go to my home directory by default. And I'm going to press enter. So it says, what's the password for my key? I'm going to type that in, and that's asking me for my ARCHER2 login password. What we can see happening now is that the file is copying. So it's transferring across. Just take a minute or so to copy. And once that's completed, I will then be able to go to a terminal on ARCHER2 and hopefully run it. And we will see that it works. And the other thing, of course, to bear in mind is that when we ran this, it had Python 3.8 inside it. We saw the message that came out saying Python 3.8.10. And of course, when we run it on ARCHER2, we'll expect to see the same. If I type Python -- version on my local machine here, I've actually got 3.8.12, so there's a slightly different version, whereas the version in the container was 3.8.10. So we can see that it is showing us the version in the container when we printed out that message, not the version in the that's locally on my machine. And we'll obviously see the same when we move across onto ARCHER2. So if I now go across to ARCHER2, so I'm going to SSH across. Okay, and if I do an ls, I should see there is my test image file I just copied. If we do an ls-l, we should see that it was copied just now. Yeah, that's right. And we could now try and run it. So obviously we've got Singularity natively installed here. We don't have to go through any Docker container or anything. We can type Singularity, it's there. And if I was to type Singularity run and then mytestimage.sif, sure enough, it's run on ARCHER2 and it's given us the output that we got on the other platform. So what we've demonstrated there is we've built a Singularity image from a definition file. We've been able to run it on a local system, in my case on my laptop, and then we've been able to transfer it across to ARCHER2 and show that the same image will run there. Of course, we're just running on an interactive login node at the moment. Things get rather more complicated when we want to run on another platform, but that hopefully gives you an example of being able to actually build an image and then just simply transfer the CIF file to another location and run it. That's probably, I think, where we want to get to at this point. There's a bunch of stuff here with some things where you might have issues. So previously there was a problem with running in the Docker Singularity container because the older version had some issues with it. That's actually been resolved in version 3.7.3, so we haven't gone through any of that because it shouldn't be a problem. Just before we finish this section and take a short break, I'm just going to highlight a couple of other things. So we looked at a very simple example of how to create an image, and we saw that we just used two of the particular sections of the definition file. So we looked at the post section and the run script section, but there's also a number of other sections that exist. Those are documented. There's a lot of detail in the Singularity documentation, but I just wanted to highlight them here and say that if you want to create your own definition files, there's these various other sections that you can use to provide other forms of configuration. We'll see, I think, a couple of them in the next section, but they are all various bits various things that exist that give you other functionality. And the other thing to highlight is that there are some additional features that we haven't gone into here, but you can look at the user guide. There's a wide range of extra additional Singularity features. And one thing I did want to point out was this ability to sign containers. So if you want to share a container image, because if you're going to transfer just an ordinary CIF file, you could obviously send it to Singularity Hub. But if you want to share a CIF image file directly with colleagues or with collaborators, then if you send them the file, how can they be sure they've received the file that has, and in a way that hasn't been tampered with, so nobody's put stuff into that image that they shouldn't have done? nobody has changed any of the code in there or whatever. And so one way to help to ensure that is by using signing of images, and there's some very useful information about how you can go about signing and verifying containers within the Singularity documentation. So I thought I would just highlight that. I think that's probably everything for that section. So what I think we'll do is we will take a break until 3, and if you've got any questions, again, we'll stick around to answer questions, but we'll break till 3, and then we'll come back after 3. We'll come back at 3 rather, and we'll then go on to looking at running MPI parallel jobs. And this is the last section of the material. Hopefully we can fit this into the last hour, but we'll see how we get on, and hopefully we'll be able to get that all going. But do feel free to take a break now, and we'll restart at 3 o'clock. And if you have any questions, I will stick around for a few minutes, and feel free to go ahead and ask.
Jeremy, there was a question there. I'm not sure I know the answer to that one, or at least I'd have to look it up, but maybe not off the top of your head. Is the Singularity signature similar to an MD5 checksum?
Sorry, I missed that. I thought, I could be wrong, but I thought that Singularity signature is using public-private key pairs. I thought it's doing digital signing using a key pair, and I guess that's not
like it's
the
PGP.
same.
PGP? Or GPG?
GPG? Yeah, I'm not actually. Yeah, I don't think. I think it's not just an ordinary MD5 hash. I would have to double check that, but I think that's the case. Yeah, I don't think it's. So I think it's not just using an ordinary hash. I think it is actually doing some sort of digital signing of the image. That's my understanding. But certainly that's something that would be interesting to go and look at. It probably tells you actually at the link that was provided there. We'll just go back and have a quick look and see.
Sorry, it's in the docs. It tells you it's a Pgp key signing.
Right. Okay. Yeah. Oh yes, indeed.
Right,
That's right. Yes. Yeah. So it uses Pgp keys and exactly, and there's all the details you can see there of how that works, and you can actually then add your key into Singularity, and you can actually create the key pair through Singularity. Right, I think we'll kick off because we've got quite a bit of material to cover. So this is the last section. So I hope people are managing to follow along. I appreciate there's quite a bit of kind of systems related stuff in this section material as well. But I hope that you're able to follow and you're finding it a useful opportunity to see how to build containers, to build images. Sorry. Make sure I get my terminology correct. I'm just going to end the poll there. I think most people seem to be back. So okay, so what we're going to look at in this final section is the process of running parallel jobs using Singularity containers. So we've highlighted already that Singularity is used much more widely. Well, it's used widely on HPC platforms and clusters. That it's not something that it's generally the solution for containers on these platforms because you won't find Docker on these platforms. And many of these kind of cluster and HPC platforms are designed for running large scale processing jobs, including parallel jobs. So this is a nice opportunity to have a look at how you might run an MPI parallel job using Singularity containers. And as was highlighted earlier on, a particular issue with running on big HPC platforms particularly is that you generally have to compile the code that you want to run on those platforms. And that's so that you have access to the libraries specific to the things like the interconnects for the high performance interconnects and so on that are used on these platforms to give you the performance for running parallel code. And those are generally things that you need to build on the platform to gain access to. And to work with. And one of the benefits of working with Singularity containers is that there are ways that we can build code on other platforms. So if, for example, on our own laptop, desktop system, using the same sort of approach that we saw just before the break, with building an image running within the Docker Singularity container and then moving it across onto ARCHER2, we can follow a similar approach for building an MPI code and still get most of, if not all of, the benefits of the performance when running on the HPC platform. So we're going to look at how that works. So for those of you that are not familiar with MPI, what am I talking about here? So I'm talking about the message passing interface. And this is a widely used standard for parallel programming. It's used for exchanging messages and data between processes in parallel applications. So when you've got a large application that runs across multiple nodes in a cluster, so you might have something which runs on multiple cores on a single node, but then it may also expand beyond that single node and run on multiple nodes. And of course, when it does, it needs some way to transfer information between the different nodes in the cluster in order to undertake the processing. And of course, there are different types of parallel applications. So there are sort of high throughput applications where there's not really a need to communicate between the different processes. And in such cases, things like MPI are not really significant. But in the cases of traditional parallel applications where there needs to be a lot of communication between the processes, then something like MPI is hugely important in enabling you to be able to efficiently communicate between the processes that may exist on different physical nodes within the cluster. So MPI is a standard that is used for that. It provides a bunch of primitives that you can use for actually communicating data efficiently between different processes within a parallel application. And within the context of containers, we've already seen how it can be impractical to build containers if you don't have root access. So we won't have that access on cluster platforms. And what that means is if we want to build a Singularity container that can take advantage of all of the kind of libraries and things, normally we wouldn't be able to build that on the cluster platform and we'd be stuck. And so what we're going to do is use an approach similar to what we used before to build our code, and then we're going to take advantage of support for these kind of parallel frameworks to be able to run efficiently through Singularity on an HPC platform. There are two kind of core implementations of MPI. There's OpenMPI and Mpitch. If our platform uses OpenMPI, then OpenMPI is very easy to access. You can go and download it. It's open source. You can pull the code. You can build it from source, and then you can move it to a cluster platform where you've got OpenMPI, and you can effectively have the same version, and it should be compatible. If you're and I should say that in fact for many kind of large scale specialist cluster platforms, they tend to have their own kind of their own install of MPI. They might have specialist libraries that are installed to support particular interconnects that they have or particular configuration of the cluster or whatever. So it's often the case that you won't be able to get exactly the same version of MPI that is installed on the cluster when you're building your code on another platform. So in the case of Mpitch, which is the other kind of widely used open source MPI implementation, there is something called ABI compatibility, which basically gives you a sort of interface, a compatible interface at the binary layer between the open source Mpitch and other MPI implementations, including some kind of proprietary MPI implementations that are used on different platforms. So in where that's the case, you can build Mpitch, the open source Mpitch code on your local platform within your image, and you can then use your image and run it on a platform which has a compatible version of MPI. And we're going to see that in the example that we show here, where we're going to use the open source Mpitch as our MPI library to build a simple MPI application. And then we're going to take advantage of this compatibility to be able to run our image, run containers based on our image on ARCHER2, which has a different but compatible implementation of MPI. So this is described to some extent in the Singularity MPI documentation. There is built-in support within Singularity for OpenMPI and Mpitch, by which they mean that there is awareness of these frameworks within Singularity, and it uses approaches to try and make the the running of MPI code through Singularity containers more efficient. And there's some detail about that in the documentation. So there's just a note here on portability and performance, and that's something which I think I've really kind of alluded to in what I've said before. There's particular challenges, especially with MPI code when running on these remote platforms, and because of the fact that on large-scale clusters, a lot of work is put into making the communication between the nodes very efficient and using specialist hardware to give you very high performance between the nodes. You often need these specialist drivers that are required to support that hardware. And so what we want to be able to do is take advantage of that while also having the ability to build our code on a separate platform that we have root access on. So that's what we're trying to kind of work around. That's the challenge we're trying to work around. And the Singularity's MPI documentation gives you two different models for working with MPI codes. There's a hybrid model, which is effectively the model we're going to be looking at today, which uses the MPI executable from the MPI installation on the host system. So in this case, on ARCHER2, it will be using the MPI installation on ARCHER2 to launch instances of our Singularity, so instances containers based on our Singularity image, and the application within the running container, so our image that we're going to use, the application that's running inside the container, as you'll see when we actually go and build it, will be linked against the MPI libraries that are inside the container. So there's a kind of two sides to this. There's the program we're going to run, and you'll see we're just going to use a simple MPI benchmarking application as our application to work with here. And that's going to be linked when it's built from source code to the MPI libraries inside the image that we build. And then on the outside of that is the ARCHER2 environment where we've got the MPI set up on ARCHER2. And the two will kind of talk to each other, and there'll be a link between the two in the way that it runs, such that we can take advantage of the performance of the libraries provided for MPI on ARCHER2, while still being able to use the code within our container that we've built on a separate platform. It's a little bit complicated. I hope that gives you some idea of what we're trying to achieve. There is documentation that details all of this, and you can go and look through if you're particularly interested to see how it works. But hopefully that gives you a little bit of a background of what we're trying to achieve here. So we're going to make the assumption that you're going to be building again here through the Docker Singularity container. So we're going to use the same approach that we used just before the break, and we're going to create a definition file as we created before. But in this time, rather than just the very simple thing running a Python example, we're going to create something which will, an image which will contain the OSU micro benchmark suite. So this is a suite, an open source suite of benchmarks for benchmarking parallel MPI processes. So what it will basically do is runs a bunch of it. We'll have a look. There's a bunch of different benchmarks within that suite that can look at the performance of communication in a parallel environment. And so we're going to run some of those, and we're going to look at sort of how that works. And this is a really nice example, because if you wanted to, you could actually use this as a basis to compare the performance of code run through a Singularity container or built natively on the cluster platform, and that would give you an idea of whether there is overhead in terms of performance there. So we're not going to go into great detail looking at that today. We're just going to look at the process of how we actually go ahead and build that and prove that we can run it. So the target platform we're going to use here is ARCHER2, and the platform we're going to build on is our local system, whatever you've been using in the previous session, within the Docker Singularity container. So we're going to start by going ahead and building or putting together our definition file. So what you need to do to be able to build this from source is you need to download a couple of tarball files for the different pieces of software we're going to work with. So you need to download the OSU micro benchmarks source code, and you need to download the Mpitch source code. So if you create a location on your machine, so I'm going to follow, so I'm actually in an ARCHER2 terminal here, so I'm going to switch across to another terminal. So this is now back on my laptop, and I'm in my Singularity data directory. And let's create a directory called benchmarks. Okay, and so what you want to do is to download the file. So if we go and look in the OSU micro benchmark site, there is a link there to the tar file for OSU microbenchmarks 5.8. So you can download that and into this directory that you've created. And in fact, I should do that. In fact, I've got a copy of it that I downloaded before, so I'm not actually sure where I put it. So I will. So what you can do is you can use a command like wget. So what I'm going to do is just copy the link, and then I'm going to go to my terminal and say wget, and give it the link, and it will just download the file. So there we go. It's downloaded the OSU microbenchmarks, and the other thing to download is Mpitch. If you go to the Mpitch downloads page, so again the links are provided there. We're looking for 3.4.3, which is the latest stable release, and make sure you get Mpitch rather than Hydra. So that's this one here. So again, I can just copy the link. Of course, you can click on it and do save as and whatever, but I'm just going to copy the link and just going to wget again in that directory where I want to store the files, and that should download pretty quickly. Okay, so I've now got two different source code for two different applications that I need. And if we switch back to here, so what we're now going to do is we're going to create a Singularity definition file. And as you can see, this one's a little bit more complex than the previous one that we looked at. And this Singularity definition file is going to build both of those applications from source and create an image that bundles all of this together. So just to walk you through what's happening here, in fact, what I'm going to do, because this takes a little bit of time to build, so you can have a go at building this yourself. There is a version of the image that's been created and made available on ARCHER2 that you can use, because it does take a bit of time to build. This machine is reasonably quick, and I think it will build in about 10 minutes or so. So what I'm going to do is I'm going to kick off the build locally, and then I'll talk you through what's actually happening while it builds in the background. So if I take a copy of that and I create the definition file here, so I'm going to call it OSU benchmarks.def. So this is very similar to what we did before. We're creating a definition file with this content. You'll notice that what I've actually got here is, and this might be something you might want to change. I've got so the -J, for anybody who's familiar with building source code, this will be something you're probably aware of. But if you're not, the -J switch says how many processes to use when building the code. So of course, the more processes you use, the faster it will build within the scope of the number of cores that you've got on your system. So if you've only got a dual core system, you really don't want to put that to more than probably J2. So this is actually a 6-core system. Just to sort of avoid it getting caught up with sort of waiting on I/O or whatever, I've increased it to be J8, and it seems to manage okay. But you might want to cut that down to 4 or 2, depending on if you've got a system with less cores, because otherwise it will just the thing will try and start too many processes, and it will all kind of grind to a halt, which we don't want to happen. So you may want to reduce that number on your system when you create the file. I'm going to leave that at 8, and I've put the one for the OSU benchmarks, which is a much smaller application and builds pretty quickly anyway. I've set that at 6, but again, you may want to reduce that to a smaller number. But I'm going to leave those at those numbers for this particular system here. So I've got my definition file, and as we did before, we're going to use Singularity build. I can't remember if I've got my alias. So there's a question there about needing to replace apt-get with homebrew. So we're building here a Linux container. So you shouldn't need to change anything in that definition file, because we're building a Linux container and these are Linux commands. So even if you're running on a Mac, as I am here, I'm running the Singularity Docker container. So I'm actually running in a Linux environment within that container, and I'm then running Linux commands to create the image, basically, inside create a Linux image. So even if your host system is a Mac, aside from the caveats of what we said before about if you've got an M1 Mac, which rather complicates things more, if you've got an Intel-based Mac, still you're running the Docker Singularity container, which is a Linux container, through the Docker desktop, which provides you with a kind of Linux type environment. So everything in that file should be exactly the same, regardless of whether you're running on Mac, Linux, or Windows. because we're running all of this in the Docker Singularity container, which is part of the reason why we're using that container. So what we're going to do, and let me just check if my Singularity alias is still active in here. No, it's not. So what I'll do is I will just take that across from here. So if I can go, whoops, what happened to my Singularity? Oh, I'm on ARCHER2. That's not going to work. Let me drop out of there. I think I've got it in here. Let's do it there. Yes. So what I'll just do actually is just get that again so you can see these. So there's my Singularity alias that I had set up. Hopefully you've still got that set in your current terminal. But if not, you can go back and get the command to copy from the previous section. So I'm just going to put that here. So there's a couple of questions there, and I'm going to answer those, but I'll just kick off the build because it's going to take a bit of time. So let me just do that. So I've got my terminal there. I've got Singularity ready to go, and I'm going to say Singularity build, and I'm going to tell it to build home Singularity, and it was OSU benchmarks.def. In fact, the thing I'm going to create is OSU benchmarks.sif. So that's the output image file that I'm creating. So I'm telling it Singularity, I want to build an image. The image name is OSU benchmarks.sif, and the input definition file is OSU benchmarks.def. Okay, I've got my directories mixed up because I think my alias was set to, let me just fix that. In fact, I set my alias to be home Singularity data, and I'm now in a slightly different directory. So I'm going to change that to be pwd. So that's one of the benefits of using pwd rather than hard coding the directory. Try that again. So I still mocked it up. Yes, I have. Maybe I've missed. Oh, I think I missed. Okay, I think I've got confused with my aliases. I'm just gonna hard code this to be Singularity data. So hopefully, if you're in the same directory you were in before, this is all working okay for you. But for me, I've created a new directory called benchmarks, which was perhaps not the most sensible thing to do. But let's hope that that will. Why is it still not working? I'm doing something obviously wrong here. But okay, let me just go back to the one level up. I'm going to put everything back to how it was, and I will come back and work out what I did wrong afterwards. So I'm going to move my benchmarks. I think I should be calling it /benchmarks, but I won't. Oh, right, maybe I was in a completely different location after all that. So, oh, okay. The problem after all that was I actually just mistyped the name of the file. That wasn't very sensible. I called it OS benchmarks instead of OSU benchmarks, so that was the problem. I'm going to put it back to where I started from, and we'll get it right this time. And then hopefully others have been more successful than me with your attempts to get this started. Right, let's try again. So hopefully the name's now correct. I've got my alias set up there. So I'm now going to tell it to build, and let's see whether that works this time. That looks more promising. Right, so it was just that I'd mistyped the name of the definition file, which was not great. Right, so that's going to start running, and we're going to get, oh, it's not going to start running. It's going to have, I forgot, I put all my files in the other location as well. Okay, I started everything in a different location, which was not a sensible thing to do. So what I'm going to do now is just move everything back to here, run it from here. I'm moving everything out of the benchmark directory. So this is all now back in the original home Singularity data directory, which is hopefully where you're also working in your system. And hopefully we will see that this now finds all of the things it needs and it gets going. And then once that does, I will come and walk you through what's actually happening. Okay, it's looking rather more promising this time. So everything is now in the right place. Okay, so I'm going to leave that running in the background, and I will talk you through what's actually happening here. So there's a few questions there as well. So so there's some questions about package management. Let me just go back, sorry, and just catch up with anything that I missed. Right. So there's a question about why not install OSU micro benchmarks in Mpitch through apt-get. So up to a point, yes, that does help with reproducibility, but there are some differences here. So one of the things is that we need Mpitch with a specific configuration, and you'll see that I've got here, when I actually build Mpitch, I build it with this with device ch4, which is so MPI is very complicated. There are a huge number of different configuration settings and drivers that it can use to give you improved performance in different environments, and we want a particular configuration here. This means that we're using a particular device setup that will hopefully give us performance that will take advantage of the capabilities on the HPC platform that we're running. And so if we just use the packaged version that is in Ubuntu, I'm not sure, but I suspect that it probably doesn't have the that particular driver set up. And then, of course, when we build the micro benchmarks, they need to be linked against the version of the library that we built. So that's why we're doing it in a manual way. But of course, I mean, this is also giving you a nice example of actually going through the process of building something from source. So it's done for that reason as well. But in this case, actually, there's a need to do that anyway. And yeah, in the case of the question about about version compatibilities. So do package managers not check for version compatibilities? No, in general. So they have their own dependency trees. So they will check for version compatibilities between the other packages within the packaging ecosystem. But that doesn't mean that that all of the libraries and whatever that you need are actually present within those things that install. So you may need something that has different configuration to what's actually installed, and that will not be to what's packaged, and that will not be checked for within the packaging system. I hope that makes sense. So there's a question there about whether Parastation is ABI compatible with this Mpitch. That's a very interesting question, and I'm not 100% sure, but there is a link to the ABI compatibility page, and I don't know if you had a look at that page. Let me just go back and have a look with that. I don't think that's listed because I'm not familiar with that version, but if we look at the ABI compatibility page, it does indeed say Parastation MPI 5.1.7 is ABI compatible. I don't know if that's a version that that you'd be using, but it sounds like there probably is some compatibility there. That I know that page looks a little bit out of date in the sense that it's talking about fairly old versions. Obviously, things have moved on, but I'm assuming that there is more general compatibility between the different providers and Mpitch going forward. I'm not sure. I'm absolutely not an expert on this at all. So, but yes, that's something which I suspect is probably okay. Did we have a question? I just heard something ping. I wonder if there's a hand up there. No. Okay, maybe it's just a message in the chat. Okay, I think that's probably addressed all of the questions.
Can I ask a question?
Yeah, sure. Go ahead. Go ahead.
So, for example, can we download this image from the Dockerhub rather than generating it from scratch?
So, sorry, this particular image that we're talking about in the context of the example here.
Yes. This the settings for MPI.
Right. So, not this particular image, but there is a version of the built Singularity image on ARCHER2 that you'll be able to use. So if you can't build it yourself, there is a version of the built version on ARCHER2 that you'll be able to use.
Okay. Yeah.
So I hope that. So you can't pull specifically this from Dockerhub, but on ARCHER2 when we move across there's a version, or in fact, if you could even use the one that I'm building now, I'll put it on there where it's accessible to everybody. So yeah, if you can't build it yourself for any reason, then you will have access to a built version of the image to test it. So you should be able to get it to run.
It looks like working, but it's very slow on my laptop, so I'm
it's quite a it's quite a big thing to build. I mean, you can see probably on the screen share there that it's churning away in the background on my machine. You might even be able to hear the fans getting rather loud. If you can, I apologize if there's a lot of noise in the background. In fact, Andy's actually got a version on Dockerhub that he's put there, so he's put a link to it on in the chat. So there is in fact a version on Dockerhub if you want to use that that Andy's provided there. But yeah, there is a version on ARCHER2 anyway, and we're going to move across to ARCHER2 and use that shortly anyway. So you'll have the opportunity to use that. So yeah, if you're having trouble building because of the speed, it's taking time to build, or it's taking time to download the dependencies or whatever, just bear with us, and when we move across into ARCHER2, you'll be able to run using the built image that's there. Okay, so right, so while that's going, let's just take a quick walk through what's actually happening here. So if you recall at the start, I used wget to just download a couple of the source files for the tools that we're going to be building, so the OSU micro benchmarks and Mpitch. And what we've done here is we've told, so we run the Singularity build command in the Singularity Docker container. And again, if you recall, the files end up in the home Singularity directory. In fact, that's why I got an error before when I created a new directory with benchmarks, because I hadn't updated this. So there's the home Singularity directory is where those files will appear. And what we've done is we've basically started off bootstrapping from the Ubuntu 24 Docker container, as we did in the earlier example. We then have this files section. So this is giving us the opportunity in the file section to copy some files into the image environment so that we can work with them. So we're taking the files that we downloaded and we're putting them into the /root directory in our image, in our container image that we're going to then where we're going to be able to build them from. We're also setting a couple of environment variables in the environment section. So the %environment section, what does this actually do? This sets things up so that whenever we run an instance of the container from this image that we're going to build, these environment variables will be set in the terminal environment inside the running container. So this is really useful. And what you can see here is we're setting up a thing OSU dir, and this is the location where the OSU benchmarks are going to be installed once they've been built. And what that means is when we run our container, we will have an environment variable $OSU dir, which will point to this location. It saves us having to type it all out every time, and we can use that as a basis to run our commands. Then we have the post section, which we saw before. So this is a bit like, as I explained before, the section in a Dockerfile where you have several run commands and you can install stuff. So what are we actually doing here? Well, we're installing some core software libraries from the Ubuntu package repository. So Build Essential gives us a bunch of basically stuff that's essential for building source code. So it gives us a compiler and all the various other tools that are required for compiling software from source. Then we install a couple of tools related to MPI. So these are drivers for interconnects, and they're used by MPI when it builds from source. It will link against those drivers, link against those libraries rather. And we're also installing G-Fortran, which is a Fortran compiler, because there are elements of the code, I think in MPI, which are written in Fortran, and it needs a Fortran compiler for those. So that's what we're installing. Then we change into the root directory, and we do something which may, again, if you're used to building code from source within a Linux environment, this may look very familiar to you. What we do is we unzip or extract the archive file that's got the MPI source in it. We change into the directory where that's been extracted to. We just print out a message to say that we're configuring and building Mpitch, and then we run this kind of fairly standard, if you're used to building from source, set of commands, which is configure, and we give it a place where it's going to install afterwards in /user, and we tell it to use this specific device, ch4 OFI. When the configuration is run, it will then run the make command, which basically does the source build. That's what it's doing in the background at the moment. So that's all the stuff you can see flying up the screen in the background at the moment is the make process. And then it will do make install, which will install the code. Then it goes back into /root again, and it does basically the same with the OSU micro benchmarks. It extracts the archive file, it prints a message to say what it's doing, and then it does again this configure and make install. Note here that when we do the configure, we tell the build of the configuration process for the build which compilers to use, and we're telling it to use the MPI compilers that have just been installed in the previous step. So that ensures that it builds the code with the right compilers for that version of MPI that we've built. And then we do the make, which builds the source code, and we do make install to actually do the install. And in fact, I think it's now in the background here, just quickly go across, it's doing the install for MPI. So it's built MPI. It's going to go through and just install the MPI code. So it'll be nearly finished, I think. So what happens at the end? In fact, sorry, I'm just checking. It looks like yes. Okay. So what happens at the end here? We put in a run script. And again, if you recall, the run script is the thing which basically says what to run when you run the container. So when you run the container, every time, if you don't give it an exec, Singularity exec with a particular command to run, it will by default run this little script. What it does is it prints out a thing which says what the rank number is. So as you'll see, when we run multiple processes, when we run something in parallel with lots of processes, every process has its own rank number, process number or ID. So we print that out, and you'll see how that's shown when we run it. And then we tell it to run whatever the executable is that's been specified on the command line. So this basically adds the name of the executable that we put on the command line to the end of the OSU dir environment variable that's added above. Basically, it means we don't have to type this long thing every time. We can just type the relative bit on the end to give us the name. Could we include the two wget commands to get the OSU? Yes, absolutely, you could do. Why didn't I do that? I didn't do that because if the thing fails when you run the command, as it did for me a couple of times, if you put the wget at the top, then it's going to try and pull the files down each time. So I downloaded them separately for that reason. But yes, you could put them if you wanted to have something that was completely automated. Then yes, you could you could certainly do that. Right. Okay. So we've now gone through what this is providing, and that's basically what is described here. And there's also some notes here which those of you with an M1 system might want to just read through in your own time, just to really highlight an alternative approach, an alternative workflow for building this as a container instead of a Singularity container, pushing the Docker container up to Dockerhub, and then pulling it down on the HPC platform, on ARCHER2 in this case. If you do want to try and do that separately, we provided the same as what we've done in Singularity here. So that's there if it's something you want to have a look at in your own time. If you do that, you'll need to remember when you run the Docker build command, if you're on an ARM-based system, to tell it to use the Linux AMD 64 platform to make sure it creates an x86 image that can be then run on ARCHER2. So that's just something for you to look at if you're having problems running in the standard environment. So now we've got to the point where we've actually got our image built. We can see here it's completed, and we've ended up with a file, OSU benchmarks.cif. If I do an ls, you can see there's the file. It's pretty big. It's 238 megabytes. I'm going to copy it up to ARCHER2 using SCP again, as we did before. There is a version on there, but this will show you that we can use the version we've literally just built, and hopefully, if anybody's having problems, you can test with this image. So if I do exactly as we did before, so you might recall that the commands that I used. So I basically said SCP, so secure copy, with my SSH key. So I'm going to put in the path to my SSH key. And then I'm going to copy the file OSU benchmarks.cif, so /OSU benchmark.cif, and I'm going to copy it to my user account on ARCHER2. And I'm going to put the colon at the end. I'm not going to provide a specific path because I know it's going to just go straight to my home directory, which is fine. I don't know if I typed that correctly. Yes, I did. Okay, so hopefully that will kick off, and that's going to take about a minute or so to upload. Go going reasonably fast. You may find if you're trying to upload it yourself that it goes quite a bit slower. You can certainly have a go, but if it's taking a long time, then you're welcome to use this version that I'm uploading now. So there's a question there: can we run MPI codes with Singularity that we just built? So yes, if you want to run locally, if you want to test run that image on your machine, you can run it. But of course, if you're not on a parallel system, you could run something which runs across, say, 2 processes on a laptop, or 4 processes, but it's not going to be demonstrating running across multiple nodes, obviously. But that's not a problem. You should still be able to run locally if you want to test it, and I can actually demonstrate that in a minute. So what have we done here? We've basically got to the point where we have been able to build a container with MPI inside it, and with this simple OSU benchmark suite inside it. And we have now gone through the process of we're going through the process of copying it over to the ARCHER2 system, where we're going to be able to run it. It's going to take only another half a minute, so we'll have a look. So yes, if you want to test it locally, you can. In fact, I will do that in a moment just to show you before I move over to ARCHER2 and do anything on there. But what I will do actually is I will just go into ARCHER2 and I'll put that image, once it's copied, into a location where you can all take a copy if you'd like to use that, rather than waiting for your own version to upload. Hopefully it will work. So we'll just wait for it to finish off. It's just about done. So it's going to finish any second now. Right, okay, so that's finished. So if I now look here, we can see that there is the image that I've just copied up. And what I'm going to do is I'm going to put that for you, so you're all welcome to take a copy of it if you want to try that image rather than waiting for your own one to upload. I'm going to CP that file into home TA049 shared, which you should all have access to. And you're welcome to go to that directory, home TA049 shared, and take a copy of the OSU benchmarks.cif from there if you'd like to try running on ARCHER2 from there. So what we will do is I'll just show you how we run this locally. So if you recall from before, if I run Singularity run, and I then say home Singularity and the name of the image. Right, so what we're going to get an error if we do this. Right, why do we get an error? Because it's trying to run something in this location, and we haven't told it what to actually run. So it's trying to run basically a directory, because that was the default run command. So the default run command puts the thing that we provide on the command line on the end of this path. So we need to tell it what we want it to actually do. So inside that suite of OSU benchmarks, there is a directory called startup, and in there is a thing called OSU hello. And that's running, so this is now running on my laptop through the Docker Singularity container, exactly as we did earlier today when we ran things. And you can see that that is the container that I've just built, and it's been able to successfully run the MPI executable for the OSU benchmarks, but it's not really doing anything exciting. It's just printing out a test message or running in a single process. And you can also see that it says rank and there's no number after it, because we're not running in an environment where it's an MPI environment where the ranks, the process IDs have been assigned. So as a simple test, we can see that the container seems to work, but nothing exciting has happened there. And we could do something a bit more interesting if we wanted. So if we wanted to try and run, so let me see what's another option here. I think there's some options on the of what to run on here. So I'm looking what might be a suitable one to test. Oh, hang on, I'm going to end up right at the bottom here. So we're going to use the gather one later, but there's another one I'm looking for, which I think is latency. Yes, okay, so let's try point-to-point. So point-to-point OSU latency, I think. So that's interesting. So that's telling us it requires 2 processes. So that requires a little bit more work, because that one, if we were doing this on the HPC infrastructure, it will fire up the two processes for us. Here we're kind of a bit stuck because we can't do that. What we could do, if you want to try this yourself, you could open a shell inside the container. You can start a container with a shell, and what you could actually do is say mpi run -np2. So that says number of processes 2, and then osu dir, and then the same thing I ran before, point to point, pt to pt, osu latency. And there you see it's done something. And what it's actually doing is it's testing messages basically across a couple of processes and looking at the latency. It's not a very exciting test on a single machine because it's just going within multiple processes running on the same node. But you can see that it has run and it's given us some output. So what we really want to do is to test something like that running on ARCHER2. So what I'll do, just in the last few minutes, I will go across to ARCHER2 and I will show you how to run that, and then we'll have just a few minutes for any questions, and I'm happy to stay around a little bit beyond the end anyway if there are questions. There's a bunch more description here, basically taking you through the process of what I've just done. So feel free to read through that in your own time if you want to go back and revisit this and have a look what's happened there. But I think the important thing to look at is how things work on ARCHER2 here, just before we finish off. So ARCHER2, as it says here, is the UK's national supercomputing service. It uses the Slurm workload manager. And sorry, there's a question in the chat there. Could you show the top command output when running MPI codes? What was that? Sorry, do you want me to scroll back and look at the? Did you want me to look at this? Was that the? Hopefully that's what you were looking for, but if not, do let us know and I can put the information up. Okay, I'll just switch back. I can switch back to that again in a minute. I'll just go through here. Hopefully that was okay. So Archer uses this Slurm workload manager to manage submission of jobs. If you've used an HPC platform before, this will be hopefully familiar to you. But if you haven't, basically what happens is there is a scheduler, job scheduler, that manages a kind of queue of jobs. And what we have to do is we have to submit a job to the scheduler, telling it the thing we want to run. So we can't just go and say run this and give it the command and it runs straight away. We pass the job configuration to the scheduler. The scheduler will decide whether it's got the resources available to run the job based on a whole bunch of different configuration options and which project we're part of and so on. And it will then, when the resources are available, go off and run the job for us and give us some output that we can access when the job is finished. So to achieve that, we need to provide a job configuration. So we've provided you with a template script here. And this is just something you can start from to configure the running of the job. So what I'm going to do again is use wget like I did before. So I'm going to copy that and I'm going to switch across to my terminal on ARCHER2. And I'm going to go to the work directory. So we can't run these jobs from the home directory. So I'm going to go, so you should also have a directory that is work, then the project code twice, and then your username. So you should all have a directory like that. I'll put CD at the front. And what I'm going to do there is I'm going to now wget that image, the template job configuration file. So you should all be able to do that. In fact, what I'll do is I'll put that also into the shared folder that I put the other thing into. I'll put that template file into home TA049 shared in case anybody wants to use it from there. And I'm going to take a copy of it and I'm going to edit the copy. So I'll keep the template and I'm going to create a copy and I'm just going to call it osu latency.slurm. Okay, right. So I'm going to now edit that copy. And what you'll see is that there's a couple of things that you need to edit. So most of it's been provided for you. So this is a standard job submission script. There's a whole bunch of these sbatch directives at the top. and these are basically providing some sort of core configuration options for ARCHER2's scheduler when it reads the configuration file. So we need to give it a job name. So I'm going to put in a job name. So you'll also need to do these changes. You'll need to, there's two things specifically that you need to change. So the job name I'm going to give it is OSU latency, and then my username. You don't have to put a username on it. I'm just putting that so that just to give it a unique name. We can see that we're allotting 10 minutes because it's a very quick job to run. So we're telling the scheduler we don't need very much time. It's not going to take even anything like 10 minutes, but that's what we're telling the scheduler we need up to that amount of time. We're going to request 2 nodes, and we're going to do 1 task per node and 1 CPU per task. So what we're going to end up here with is two CPUs, hopefully on 2 different nodes. That's kind of what we're asking for. We've got a couple of other things here. We're using partition standard, and we're using the short quality of service. These are all things that are detailed in the ARCHER2 documentation. If you go and look, it explains to you what all the different options are and what they mean. But this is what we're going to use for this. And we also need to provide our account code. So you can remove the placeholder and put in your account code there. That'll be the same as for me, TA049. And everything else there is pre-configured for you. So what we're actually doing here is we're loading a module for the Mpitch libraries. There's some other standard configuration. We're setting this OMP num threads environment. As it says there, prevents any threaded system libraries from automatically using threading. That's, I guess, is something specific to ARCHER2. And then there's a couple of Singularity environment variables that are set, and these are setting paths to a bunch of system libraries that are specific to the high performance interconnects set up on that platform. These are things that you wouldn't be expected to know yourself. They would be provided to you by the system operator, and indeed, if you go and look in the documentation for ARCHER2, these kind of options are provided. There's a section on containers which provides this information. And then we actually run the job. So we say srun, that's the thing we use to run the job. We provide a couple of particular parameters there. And then we say the job we want to run, which is Singularity run our container OSU benchmarks, our image, sorry, OSU benchmarks.sif, and then the thing we want to run, which in this case is this point-to-point OSU latency, which is the example that we showed there. What this will do is then it will go off and the scheduler will run the number of processes we've asked for, in fact 2 processes in this case, and for each of those processes it will start up an instance of the Singularity container, and the 2 will be able to communicate with each other via the MPI framework based on the configuration that's set up on the system. So that's basically all we need to do to get it to start the 2. We use srun and we tell it to, and srun is the wrapper around which we'll start up the multiple processes and so on. And that will actually get these 2 instances of our container running. Each instance will run this OSU latency executable, and the 2 will then be able to communicate with each other. So that's what we're aiming for. So if you've got this template file, so you don't need to download the benchmarks on ARCHER2. You just need to use the OSU benchmarks.sif image file. So that's all you need access to, and that's what if you haven't been able to build it, that's what I've put into the /home/TA049/shared folder. You can get the copy of the image from there. So if we save that file, so we've now got our OSU latency.slurm submission file, and what I can then do is use the sbatch executable to submit it. But I first need to make sure I've got the image file locally in this directory. I don't know if I have or I haven't. It appears that I have. I don't know if that's the latest version. I'm going to copy the version from home, the one that I just put in there, TA049 shared OSU benchmarks.sif. I'm going to copy it to here so we know we're using the same version. And we're going to say sbatch, which is how you submit the script, and then the name of the script to submit. So it tells me it's submitted batch job 998213. If I do sq and I put -u and then my username, what we see is that my job is in the queue. I'm not quite sure what CG is. Maybe it's just finishing.
That means it's finished and it's just exiting.
Oh, okay, fine. So it suggests that it's already run. So what I can then do is if I do an ls, and I'm going to do an LRT, so it shows me the file outputs in order, in time order, and that's the most recent output file. And in fact, the number 998213 corresponds to the number of the job that was submitted. So we know that that's the output file provided for that job. And if I look at that, we should see the output from the job. And hopefully, yes, indeed, we do. So we see that it's actually run. And what we also see here is the rank numbers are provided. So we can see there were 2 processes that started. And they ran this OSU, each one ran the OSU latency command. And then the 2 were able to communicate. And this is telling us basically the amount of time that it took, the latency rather, for communicating messages of these varying sizes. So this is kind of the number of bytes, I think, of the messages that are being sent between the nodes. So we've actually been able there to run a parallel MPI job. It's a very simple example, but it does show that we've been able to build something from scratch on a separate platform, move it across onto ARCHER2, and then run a parallel job via MPI. Hopefully, some of you have been able to get that to work. So there's a question there: how did the code detect MPI run? So in fact, this is all done behind the scenes by the Slurm workload manager, and that is basically the MPI, the running of the MPI daemon, whatever, is all handled by that. So in fact, as Andy's put a message there, basically running the srun is equivalent to running MPI run. I'm just looking. There's another message there with a permission denied issue. Okay. So in fact, the message you've got there should be okay. It just looks like it can't. It's so when you ran the. I'm just looking at the error there with the P2P gospels, and that doesn't look great. Right, so somebody's asking to see the job script. Yes, so let me just so all that I changed in the job script, I used the job script that came from the template that was on the web page, and I literally changed 2 items. I gave it a name, which you can choose whatever name you want. Sorry, I'll go up to the top. So the only things I changed were I put in that name. You can put in whatever name you want for your job name, and I put in the account code, which is there. Those are the only 2 items, and there were placeholders in the file for those 2. So nothing else has been changed there. And you need to run. Yeah, you need to. Sorry, there's a point there. You need to run from the work file system. So I realize we've covered a lot of material, and we've gone through it very, very quickly. But hopefully this gives you an idea of kind of how all of this fits together. It is quite I guess a complex topic of going through all the different processes of building things. But the kind of the building blocks are all there, and hopefully all of this material, obviously the material's online, you can go back and revisit it, and hopefully this gives you all of the kind of the basic knowledge that you would need to be able to do this. I'm happy to, as I say, so we're kind of pretty much at the end now. I'm very happy to stick around and help people who've got any problems. Obviously, I do understand if you need to head off, please do. But certainly, I'm happy to stick around, and I'm sure Andy's probably able to stick around for a few minutes as well, and answer any questions. But I think at that point, I'll just make a couple of kind of closing comments, and then we will we'll wrap up for today. So, as I say, we covered a lot of material. If you recall back to where we started this morning, we went literally right from the start of just looking at the very basics of Singularity, looking at how we could pull images from the Singularity hub and then from Dockerhub and run those images, run containers from those images on our local system, or rather on ARCHER2 initially, and then we looked at how we could run it through the Docker Singularity container on a local system, and we've then kind of built up from there through the process of actually looking at how you would build a Singularity image and how you would build a definition file to support the creation of an image, and then moving through to the process of actually building a much more complex MPI example and getting that to run on ARCHER2. So a lot of stuff there has been covered, and as I say, the Singularity is developing all the time, and I suppose that this is not yet quite as optimized maybe as working with Docker. Definitely, as you can see, there are things like the fact that you can only install it on Linux at the moment that make things a little bit more challenging. But it is certainly a very useful tool, and it's something which is being used increasingly widely on HPC infrastructure, particularly. And it's certainly something that's very useful to understand. And if you're working on scientific work with HPC platforms, it gives you a great opportunity to be able to build stuff locally, and then to be able to work with that and to do debugging and things locally on your system, and then to be able to take the image across and run it on an HPC platform if that's what your aim is. So with that, I'm going to wrap up for today there. And do feel free to stick around and ask questions if you're stuck with getting things to run and you want to go through things. I'm very happy to do that. And otherwise, I hope you enjoyed the course. I hope you found it useful. The videos for the course will go up online in due course, so you'll be able to go on the course page and go back and kind of revisit anything that you want to look at again. And otherwise, hopefully all the materials are available. You've still got access to ARCHER2, I understand, for a little bit of time. I think Andy said maybe 3 or 4 weeks after the course. So you're welcome to go back and have a look at things and try things out. And otherwise, thank you all very much for attending. Thank you for all your questions. It's been great to have so many questions and so much interaction from everybody, and to be able to go through everything. And I guess, Andy, did you want to say any closing comments as we wrap up?
The only thing I want to, or 2 things I would say. One is you'll get a request for feedback on the course for our training administrator, Claire. Please do fill in the feedback, both good and bad, because it helps us improve the course and improve the training so much. It's really, really valuable to us. So do let us know of things you think could be improved, of things that went well, things that didn't work so well, and that's really helpful to us. I mean, and secondly, I just want to thank you all for being so engaged and asking so many good questions. I'm aware that it is harder in a virtual environment, although it does give an opportunity for people to attend the course who wouldn't otherwise have it, so that's great. But it does make it more difficult to interact and have questions, especially when my camera doesn't work. I don't know why that doesn't happen, why that happens. So your input and enthusiasm is really valued by ourselves as well. You're an integral part to making this course enjoyable. So thank you so much for sticking with it and putting it and engaging so well.
Yeah, absolutely. I second that. It's been really good, and certainly really enjoyed teaching the course, and I hope you've enjoyed attending it. And good luck with your use of containers in the future. I hope you find it something that's a useful technology for your work. There's a question there whether there's a feedback form. Yes, I understand. Andy said that the feedback form will be sent round by the organisers of the course. That's right, isn't it, Andy? So. So if anybody's got any questions, so as I say, obviously I know people are heading off, so that's fine. If you need to go, then please feel free to go off. But if you've got any questions, you're welcome to put questions in the chat still, or to unmute and ask questions if you would like to. I'm just going to put a light on, and I shall be back in a second.
Roshan, the feedback link will be sent via email to the course attendees just after the course. Jamie's asking about GPU pass-through and Docker and Singularity. So yes, Singularity does indeed support the use of GPUs. I'll try and find the actual docs. And I think it has separate options for passing through both for NVIDIA and AMD GPUs. I suspect that the NVIDIA GPU implementation is more tested and robust than the AMD stuff, because AMD GPUs for HPC have only just sort of been coming online properly. But I do expect that to get a lot of testing and a lot of updates as time goes on, because a lot of the big US exascale systems are based on AMD GPUs, and Singularities are driven from a lot of the, or at least Aptainer version of Singularity is driven from the US. So I suspect there'll be a lot of activity there if the AMD stuff's not working already. Oh, that's an old version of the user guide. Sorry, my link. Yeah, I've chosen the wrong
No, it's
one.
fine. This is actually even the 3.7 version is. I mean, that may be a little bit out of date still, but I don't know whether there might be even a more recent. Well, there will be a more recent version, but I'm not sure. I can find the more recent version here, I guess. Oops. There we go. Docs.
So you could just mangle the URL and put 3.8 in instead of 3.5.
Oh, okay, fine. Okay, I'm just looking what the latest version of the documentation is. There's a here in the main section, so I guess can we just put GPU on the end there and get to the GPU page? Yes, we can. So that's obviously the latest version, I guess. But it's probably very similar to the other one. So the question: how do you? Oh, sorry. Good.
Sorry, I was going to say, Joris is asking how you can build the OSU benchmarks on ARCHER2. Yeah, you can change the prefix. You'll need to change the MPI, the compilers as well. The compilers on ARCHER2 are not MPI CC and MPI capital CC. It's CC. Oh, sorry for C compiler. I can give you the full recipe, but.
Right. Okay. So is there some? Do you have to the module? Oh, okay. That's great. So that just comes as a result of loading that module. Does it create Mpitch API?
You don't need to load the module; it's automatically loaded for you. All you need to do actually, you will need this just that command first to switch to the GCC compilers, because the default compilers have some problems compiling the OSU benchmarks.
Oh, okay.
So just give me a second. I'll get the full recipe for you.
Okay, excellent. That'd be great.
I just need to double check it works.
Oh, right. So we've got something there. So if you copied the OSU benchmarks.sif from the shared directory, so when you just run it on its own with Singularity run, that's just running the default run script, which doesn't actually have it's not telling it to run any command. It's just got a sort of prefix for the location where the commands are. So what you need to do is after the end of Singularity run OSU benchmarks.sif, you need to put the name of the thing that you want to run. So if you just want to just do a basic test running it directly, then you would use something like startup /OSU hello. So let me just put that into the chat and you can see. So if you ran something like correctly, Singularity run, and then the OSU benchmarks.sif, and then something like startup /OSU hello. Right. So if you run the command that I've just put in there, you should get the initial just the sort of single core single process startup thing to run, and it should just give you a message out that says that it's run. That's the kind of the most basic test. And then if you want to go beyond that, you probably want to look at submitting a job script. So there's a few examples. Sorry, yeah, there's a few. It was not as straightforward that as it could have been. There's a few examples here. Let me just find the section where there was a few examples of different commands that you could run. I did actually see it on here. I'm sure I put it in, but maybe I'm missing it somewhere. Here we go. So I'm just about just over a third of the way down the material. There's a few examples there. I mean, there's a whole swathe of different benchmarks that can be run. That's just a few of the examples. But anything that runs across multiple processes, rather than running them just on the interactive login node of ARCHER2, you'll want to do a job submission with the template script. And so if you look at the template script that is provided, I don't know whether if you got through to that point before, but if you missed that, there is a section here with a link to the template script which you can download, and that template script looks like what's on here. So this is the actual template script, and what I've done here is you will find that if you open the template that you download, there are two things that need filling in. One is that you need to provide a job name, and you can put whatever you want for that. That was just what I made up to put for my job name. And then the other thing you need to provide is your account code, which tells the scheduler which course you're on in this case, so it knows who to allocate the usage to. So those are the two things that need changing. And then once you've done that, you can then set the command to run at the bottom. So by default, it's set up to run the point-to-point OSU latency, but you could change that to one of the other commands that I was showing you in the example here. So if I go back up to wherever it was, somewhere around here, so you could find that there. Thanks for that, Andy. I wonder if it's worth putting that into the material.
Yes, I think it probably is. We should do that, and then you could run both actually in the same job script, and you get the output from both, and you could look at the difference in performance.
Yeah. Okay, I'll put a note to do that.
So yes, the compilers were already loaded. It's just that the default compiler environment on ARCHER2 is the Cray compilers, not the GNU compilers, and the Cray compilers have some problems compiling the OSU benchmarks. Jeremy, I'm afraid I'm going to have to head. Yes,
sure,
so
that's
Joris,
no problem.
I'm going to have to head off. Joris, yes, it's no problem submitting using make-j with submitting job. We have controls on the login nodes that mean that one user can't cause problems for the others. So use what you want, and it's up to the system to control it and stop it hitting other people.